Hi, me again. So, second vid for this one-off lesson to do with hypothesis testing. We've just gone through a full hypothesis test there with a critical value and the conclusion together there. An ASTCC, that's how you set it out every time. And I was seeing if my R value was sufficiently away from what the R value in the critical values table is for there to be an issue. And I'll test it against no correlation. So look at what mine is and say, R is minus 0.9, so it's got to be a strong negative correlation. But is that minus 0.9, oh sorry, 669? No, it is. Is mine minus 0.913 far enough away from the value in the tables on page 8 of your pack? If it is, there's an issue. But it could be you do another sample tomorrow and it's not. That's the problem with sampling. Right, so let's jump to page. It's about 15 pages, I think. Yeah. So the one tail, if you do a two tail, you look along that second line down, and it halves the value that you're doing at because it splits it. So it splits your significance. It splits the significance half each end. So if I was doing a 5% significance level, for a two-tailed test, it does 2.5% at each end. There. So I've got to double check if it's one tail or two tail. So we'll practice these anyway. And remember to sort the sign out as well. So we just need to practice these to be fair. So we've got these critical values there, so I'll plus on mine. Right, let's have a look at this second example then. So it says, it's been suggested that babies take longer to learn to crawl in the colder months. So we've got longer to learn to crawl in the colder months than in the warmer months. So we've got a study in the USA recorded the average daily temperature. So you've got to be really clear what this is. So average daily temperature and the age that they start walking at. Right, now then, I'm just going to pause it. What I want you to do is put these values in list 1 and put these values in list 2. Okay? And then, right, so I'm just going to pause it and I'll get the calculator up. Right, so I put my numbers in, hopefully they're alright. Let's just double check the calculus sets up right. So F2 for calc, if you've not already pressed it. F6 for set. List 1, list 2, list 1, list 2, 1. Good. Right then, so it says here, so enter the X data into list 2, enter the Y data into list 2. Calculate, and then F3 for regression. So F3 for regression, F1, and then F1. There. And it gives us an R value. So we know that the R value is minus 0.7084. And I want to see if that minus 0.7084 is far enough from the critical values in the table for it to make a difference. That's what I'm doing. So what I want to see is minus 0.7084 far enough away to make a difference. That's what I'm trying to say. Right, and so I need to set this test up, don't I? Okay. Right. So it says, carry out a hypothesis test at the 1% significance level, so 0.01, to determine whether the PMCC indicates an association between X and Y. It doesn't say a positive association, it doesn't say a negative association. It's vague. If it's vague, it's a two-tailed test. There. Right, so let's set it up then. So my null hypothesis. So remember, NASTTC. Not all stats teachers call it. There was another one, but I'm not going to say it on here because it's sweaty. So H0 is that rho is equal to 0, that there's no correlation. My alternative is that H1 is that rho is not equal to 0, that there is an association between them. My significance level is 1%. My tail is a two-tailed test. So what I'm saying is that 0.5% is split at each end. And I want to see if that minus 0.7084 is far enough away for it to make a difference. That's what I want to do. Right then, so my test stat is that R is minus 0.7084. If anybody kind of does psychology, you do loads of this hypothesis testing. Then I've got C, which some people say is a critical region, some people say is the conclusion. Right, so let's be careful here now. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is 11. It's two-tailed, and it's 1%. Right, so everybody flick to the back. So remember this, n is 11, two-tailed, 1%. So go to page 8. So n is 11, two-tail is the bottom, and it's 1%. So if I go across the n is 11, and two-tail at 1% gives me 0.7348. Now, because it's two-tail, I do plus or minus. If it was a greater than, I do plus. If it was a less than, I do minus. Because it's two-tail, I do plus or minus. So, let's draw a picture then. I like a picture. I like these for the fact you can draw a picture. So my critical value from this is plus or minus 0.7348. So here is 0.7348. So anything up there is a reject, and here's a minus 0.7348, just keep an eye on the time. So if it's in here, I reject H0. It's far enough away, my test stat is far enough away for to say, ooh, do you know what, there's an issue here. Then I've got accept H0. Now my test stat is minus 7.0, so my test stat is minus 0.7084. And if you look, it doesn't lie in the critical region. So these are the critical regions. And the value, the 7348, is a critical value. So because it doesn't, we accept H0. So for this one, we're going to say that we accept H0. So what I could do is I could add in here that minus 0.7084 is greater than minus 0.7348, and it matches what we did in the last one. So we accept H0. There is not, so it's very, very specific how we write this out. There is not sufficient evidence at the 1% significance level to suggest an association between the age, you've got to write a lot for this, the age a baby walks, I've got to watch the timer, 9 minutes 30, and the daily time. Right. There's one for you on the next page, I think. So I'll have a go at that one. And then I think that's it. Well done, everybody. Bye-bye.